Ashok Sridhar spent his whole career in 3D manufacturing. Since he arrived in Holland, he focused on printed electronics. Now he's the CEO of Tracxon, a company that focuses on printing electronics on flexible foil. I sat down with Ashok to talk about his ambitions and what he thinks, what kind of role Tracxon will be able to play in this market. Ashok, can you tell me something about your background?
Yes.
Maybe about your roots. Were you born in Holland or in India maybe?
Born in India, 1980. So the first 21 years of my life I lived in India, in a city called Madras or Chennai. That's in southern India, big city known for automotive manufacturing and good food.
Spicy food.
Spicy food, but always hot and humid weather. Our winters are like 25, 26 degrees. That's what we call winter, and the summers are pretty hot and very humid because it's on the sea, on the coast. Did my schooling there and also a bachelor degree in mechanical engineering for 4 years, followed by 1 year at Caterpillar in India. That's the big mining machine making company, American company. I was one of the first 4 employees in that company, selected as part of future management, so-called graduate engineer trainee program. Great 1 year, I learned a lot. I was a hardcore automotive guy back then, but I realized always there is a need to learn more. And at that time, German cars were my favorite, especially Mercedes-Benz, growing up in India. So I moved to Germany in 2002 for a master's in Aachen, University of Aachen, that is RWTH, one of the better universities in Germany, for a master's in manufacturing engineering. So I focused on, again, manufacturing, focusing on automotive applications. And during that time, it was like a dream come true. I worked as an internship student at Mercedes-Benz near Stuttgart, the biggest factory of Mercedes-Benz in Sindelfingen. And that was like a full-time job for 1 year. So I was like a kid in the candy shop, learned a lot of things. That was 2003, 2004. That's when I first started to work with 3D printing. That was inside Mercedes research. I was given the responsibility as an intern to work with 4 different machines of 3D printing. So ever since that time, I have been in additive manufacturing. So 2003 until today, starting with 3D printing, moving to printed electronics, that's my career background. And then in 2005, end of 2005, I came across a PhD position at the University of Twente in Enschede, Netherlands. Also for 3D printing, but for electronics. So from one day to the next, I came across the border. I went from automotive to electronics. So 2006 January, I started my PhD. Now it's 20 years in printed electronics. First as a researcher, then as a business developer, now as a startup CEO.
And where was your PhD about?
It was about printing of electrical circuitry on so-called circuit boards, printed circuit boards. The project was defined by Thales, Netherlands, and also Astron, the Radio Astronomy Institute, to be able to print circuitry and sensors in an additive manner. That was the early days of printed electronics. So I did my PhD for 4 years. Then 1 year I went back to Germany as a postdoctoral researcher at Fraunhofer, also on the same topic, printing of circuitry. Then 2011 mid, I moved back to Netherlands to TNO to start my career as a TNOver, 4 years as a researcher, then later 4 years as a business developer. And every time, all the time, it was always about printed electronics.
Just to get the time right, when did you go to TNO?
Mid of 2011, indeed, I went there. Stayed 4 years. That's a department called Holst Center in Eindhoven on the high-tech campus. Did 4 years of, as a researcher, hands-on printing and assembly of components and so on. Then in parallel, around 2014, to 2016 actually, I did an executive MBA at TIAS. So TIAS Tilburg. So every weekend I was studying and every working day I was working at Holst Center TNO. And once I was coming to a close for my MBA studies, I moved to a company called SABIC. SABIC used to be GE Plastics, also in Bergen.
It originates at DSM, I guess.
Exactly. They are located also in Geleen on the Limburg side, but also in Bergen op Zoom. So I was at Bergen op Zoom as an application specialist, also for printed electronics applications. Then I moved to a business development position. Then after 2.5 years roughly, I moved to a company called LuxExcel.
Yes, I know that.
Yeah, LuxExcel is of course very well known in this region.
Meta is now the new owner.
Exactly. It was a very good thing that happened to LuxExcel, but when I was there, we did amazing things, but Meta was not yet in the picture. I was there for 1.5 years as a strategy director working with the chief commercial officer. But at some point down the line, I realized, well, I might want to go back to TNO Holst Center due to two reasons, but one of them mainly is to also to work on startups. So I moved back to TNO Whole Center in a business development position, but with an additional responsibility to help create startup companies. So I did business cases for 3 of them, of which Tracxon was one, and I myself moved out as a CEO of the company. That's kind of
how you started.
Exactly.
So there were actually 3 companies that you worked at, which had to do with printed electronics at TNO.
At TNO, yeah.
They all had to do with printed electronics.
Yes, because all these 3 came from Whole Center, and the focus indeed is printed and flexible electronics. And then Tracxon is also much broader in scope because it's a manufacturing company to start with. It's a complete printed electronics portfolio in one company as a manufacturer.
Yeah, what attracted you to Tracxon?
As a business developer at TNO Whole Center, I have been lucky and privileged enough to be able to visit almost every manufacturer and every player in printed electronics. I also had the opportunity at SABIC before, so I knew this entire ecosystem. What we found out is that TNO Whole Center is very advanced in terms of technology, in terms of prototypes and lab scale processes. But if you look at the commercial manufacturing side, other companies were trying to emulate, but they were far behind the capabilities. Because if you look at printed electronics, it's actually the circuitry that's printed, then you still need to assemble chips and LEDs and batteries and so on, unprogram them and encapsulate them, so it's a complete value chain. There was not a single company that could do everything. So we thought, well, TNO has great innovation, now let's take it and scale it as a first fully integrated manufacturer. And that challenge attracted me. And if we are successful, and thankfully so far we are, we'll be able to change the way electronics is manufactured, so the impact is much higher. And that's what also encouraged me to move to Tracxon.
So what year did you join Tracxon?
Tracxon was officially formed, created in January 2022 with 3 co-founders. Myself as the CEO, Corne Renthrop as our CTO, and Raghu Pendyala as our operations officer. The 3 guys basically came out. That was January 2022.
At that time, what was the status of the company? What was the basis, and where could you start with? Was there already machinery developed, processes developed? Can you name one after another?
Sure. 2022, the company was officially formed and then registered in the Chamber of Commerce. Almost a full year in 2022, we were still at Whole Center building, doing things using the facilities there, lab scale facilities, some subsidy money, but also the first paying customer. So it was more a part-time exercise in the beginning. And we moved to this facility you see here end of 2022. This is where the full-scale manufacturing was set up. And the first year was indeed trying to understand the market, trying to create interest, continue the customer relationship which I had built from my previous job at Whole Center, and then translate them into potential customers for Tracxon. That was the whole first year.
What is the customer? At Whole Center you had one customer, you said. So what kind of product did you deliver to that customer, and what was actually in the beginning the main focus of the company?
Yeah, the very first customer is a company called Mink Tech. It's a German company, it's a small company, also a startup like us at the time. They had this very nice special sensor, very long sensor for spinal health monitoring, for back monitoring. So how is your posture? Are you sitting properly? And especially good for rehabilitation, because when people have back injuries, they have to avoid certain postures. And this sensor needs to be extremely thin and lightweight and flexible because it has to constantly monitor the back. And Whole Center's printed electronics is highly suitable for such an application. They were our first customer. We were able to showcase to them that, hey, look, with printed electronics, your concept can be realized in an effective way. And then we had already, thanks to us being part of the whole TNO ecosystem, a lot of Whole Center customers already were looking for, hey, we have a nice prototype device from Whole Center TNO. How do we upscale them? And then directly they came to Tracxon because we were created as an entity from Whole Center. That's how the second and third customers came into picture.
Uh-huh. So there were really customers with a need for mass production.
Yes, and mass production as in, of course, these are initially the typically wearable and healthcare device. So it cannot go from prototype to directly to mass production because they have to go through market validation, they have to go through CE or FDA approval. It all takes time. So initially they were all projects that are for prototyping and small batch and clinical studies oriented manufacturing. And now, after traveling the journey with them for almost 3 years, a few of them are going towards full scale manufacturing, and that's what we are doing today at Tracxon. We go through the full journey with them.
All those demands, didn't that blur your focus?
This is something we have always been asked and asking ourselves, should we focus on one product, one type of product or customer? But at the end of the day, as a manufacturing company, we are not a product company. We are typically a B2B service provider so far, which means it's important to have multiple customers to create a factory out of it. If we are a product company, hey, look, this wearable health patch is our product. That's our only focus. Could have been different. But as a services company, we are looking at, if we set up a factory, how can we fill the machines here and keep on rolling this innovation forward? And that's the reason to attract and adapt more customers as we go forward. But after a certain point, especially with investors who came in at early stages, we were a bit selective in saying, okay, this project is okay, but this is not okay because there is no potential, or it's simply going to eat our time fully. So then the balance came a bit later.
What is actually your business focus? What do you sell? Do you sell equipment, or do you sell a process, or do you deliver a product that is tailored to a customer's needs?
So when we go from a lab to fab as a technology provider, as a manufacturer, the proof of burden is on us, which means the companies who are interested in our technology, they look for, hey, Tracxon, you're going from a prototype at whole center for a wearable device or an IoT device, and you say you can manufacture, but can you prove you can manufacture at the right scale, quality, yield, and cost, and so on and so forth?
What do the customers actually bring? Do they bring a design, or do they bring a product idea? Is it just an idea and they come up with, I want a wearable tie, or I want something which can be glued on the knee?
For that, maybe shall we take a step back, because it's important to express the vision why we created Tracxon. If we go all the way back, it's to create a sustainable manufacturing technology, because printed electronics, you will see of course a bit later as well if we discuss in detail, is much more material efficient, resource efficient, lower CO2 footprint, and it's also possible to manufacture here in Europe. So that is the basis. And then the question we ask ourselves is, how do we get momentum? We don't want to be confined to being a small company. We want to create a global impact. And what is the right business model? Well, we work with customers who have these unique ideas that can only be made by printed electronics, but at the same time also customers who have a traditional PCB that's made by etching processes. They want to go towards more sustainable processes. So they are also a customer. So to answer your question, some customers just have an idea which we translate and co-design and co-develop and manufacture. But some customers say, hey, here is my current product PCB. Can you make this a printed electronics PCB with all these specifications? So until now, we have had 25 customers, and the mix is quite even, I would say.
It seems to me very hard to focus.
As a manufacturing services provider, you get all kinds of queries, of course. Then you also need to prove the technology. We have successfully done that. Now, in the last few months, with new investors coming in, now we are financially also secured. And in the meantime, we have created a lot of unique equipment patents and designs. Why is that necessary? So far, we have been taking TNO's processes and using equipment available in the industry in a customized manner, and trying to create unique products. But we could see a lot of gaps saying, hey, now if you take a PCB, a printed circuit board, it has so many layers, it has a so-called via interconnection that connects two layers. In printing, that's not possible. Voila, there came the idea of the world's first via printing machine. So with the new investors coming in, we slowly pivot towards an equipment and a solutions provider. So what's going to happen as we speak, if you go into the clean room, you will see the world's first prototype of a roll-to-roll via printing machine. And once we have it, we will prove it by producing a Tracxon. Then eventually we will start commercializing it. So there is an evolution in business model from being a manufacturer or the service provider towards a manufacturer and supplier of turnkey machines.
Yeah. And in your process, the process that you have here in the factory, there are off-the-shelf products which you buy on the market, and you combine that with machines that you developed yourself.
There's a bit more nuance than that. Let's split these into multiple pillars. Let's look at design rules. Let's look at materials. Let's look at processes and equipment. There are 4 pillars. Yeah. Design rules. Why are others not able to do printed electronics in the way that we can do? 500 plus person years of R&D from TNO has gone into creating the design rules. No one can take a PCB, printed circuit board, and replace them by printed electronics using the same design rules. Completely different. So design rules. Second one is the materials know-how. TNO, but also Tracxon, we just buy materials, but we know which material to buy from which supplier for which applications. And it's not one layer, it's just sometimes multiple materials stacked on top of each other. How do they interact with each other? The combinations can be mind-blowing. This is something we also developed further from TNO's basis. Third one is processes. How do we bring the material and design together into viable processes? TNO did that in a lab scale. We have upscaled it into a production scale. And the last one is indeed the machine. So far we have been implementing these in commercially available machines, but now we are creating customized machines that are efficient, energy efficient, higher throughput, and also be able to realize more complex products. Now we are bringing all of them together as the first full solution provider of printed electronics. That is the kind of the full story around it.
Yeah, seems to me that you have to handle a lot of tasks.
A lot of tasks.
And with how many people do you do that?
So right now, as we speak, we are hiring 10 people. We recently closed a funding round in August this year with 3 investors. So we are hiring 10 people, but until now, until let's say July or even August, we had 22 people, both full and part-time. So as a startup, of course, we have to make use of all the smart students as well. So we had a number of students and a few TNO employees who also worked part-time at Tracxon. And of course, 10 full-time employees at Tracxon itself. So going from 22 to 32 in the next month, that's what we do actually. That's how we grow.
You talk about those 500 person years of experience in printed electronics. Where is that knowledge? How can you access it? Is it in databases? Is it in people? Where is the knowledge, and how are you able to use this in your company?
That is extremely important because, I mean, sometimes people come and go over a period of 20 years. For example, at TNO, that's possible. So a lot of these design rules have been captured in documentation. That's very important. And the question can be asked, okay, this documentation can be also supplied to other manufacturers and they can read and find out. No, that's not possible because the people that co-created those documentation and design rules, they're also here at Tracxon now. So I can say out of these 22 I mentioned, 7 people work either full-time or part-time at Tracxon, including the 3 co-founders. So we also co-created that and we are here now, so we can build on that further. So it's not a static situation, it's a starting point on which we have built further at Tracxon in the last 3 years. Yeah. That's our competitive advantage, yeah.
Yeah, so you have a lot of different products. You see here this foil, and here's a more traditional printed circuit board. Yeah. Is this printed with your equipment?
I have the fullest respect for it. Without this, the modern world doesn't exist. Printed circuit board, but this is not printed. The only thing that's printed here are the etch resist here, and also these characters you see. But the full circuitry, it's all etched by chemical etching. Each layer has to be etched by multiple steps and so on and so forth. So it's technically it's not printed. But if you look at it closely, it has so many layers, fine structures, and many VI interconnections. If you look at this one in specific, it is super lightweight, ultra thin. You can print circuitry like you print on newspaper, but the drawback is the complexity level is less compared to this one. And that's exactly what we are addressing with this first via filling machine. So we can print on both sides and also interconnect them without having to have an external connection. Because this, you drill a hole and this goes in a plating bath. And the plating material flows into it and they plate the holes. That cannot be possible by printing.
So you're working on 2 layers, it's not multiple layers.
It is multiple. So we have the first thing is to work on 2 layers from side A to side B. But the next step also with the same machine is to be able to interconnect on the same side with so-called blind vias. These are through vias. And there are the other ones between layers are blind vias. We are creating both of them. So eventually when the machine is ready, we can do up to 6 layers, 3 on each side. And then if you look at the market, 1 to 6 layers covers more than 65% of the PCB market. So that's big enough for, we don't have to replace everything.
Why don't you focus on PCBs for standard electronics as a sole focus?
This is a very important point. End of the day, sustainability-wise, recyclability-wise, this is very poor. But in terms of functionality, it's extremely good. So what you see here are copper tracks, for example. These are bulk copper. Their conductivity is 1-to-1 as a full, almost 100% copper. But the printing inks, they have either silver or copper nanoparticles or microparticles, and they are bonded or bound by polymeric matrix. There are solvents and so on and so forth. So the highest conductivity you can reach for the same structure size is about 20% of this one, which means standard electronics needs power electronics, for example. It needs probably 10 layers of circuitry, but also it needs components that are also huge and needs a rigid support. That's why we are not focusing on one-to-one replacement of all standard electronics. We are picking out the key applications. What are the key applications? If you look at the trend in healthcare, it goes towards remote patient monitoring and home care, which means literally hundreds of billions, with a B, devices are needed to monitor people at their home settings. These are also PCBs. Even though we don't call them printer circuit, but they are PCBs. If we don't print, we will use these to do that. And the next one is IoT, Internet of Things. McKinsey, I think about 8 years ago, McKinsey and Company predicted that in the not so far future, we will need trillion sensors per year. With a T, trillion sensors every year. And you also see the trend with AI. Everything will be sensed and connected and processed and so on. So how do you ensure these devices, these functionalities are realized without having to go for yet more of these? That's what we first focus on. The bulky ones, the heavy electronics, the power electronics, they will hopefully follow in the future. That you ask for focus, that's our focus.
So your customers will actually be device makers or sensor producers who ask you to produce a PCB or even a print for their product.
Currently, this is exactly the evolution so far, and also for the coming 2 years, so until 2027 end. These are the companies that want to produce, want to market IoT devices, want to do wearable devices, and a few, many type of sensors, like for example, these glucose patches and so on. These are the main customers. But as we go forward as an equipment solution provider, our goal is to be able to convince with the combination of these four, I mentioned the design rules, the material know-how, the process know-how, and the machines, to tap into this big industry, and that is the Flextronics, the Jabil, and the Molex of this world, who make these electronics in huge quantities. Yeah. They don't care about just printing or just assembly or just programming. They want to have a full solution. If we can establish enough proof points at Tracxon, one by mass manufacturing saying, hey, we can meet the quality, yield, and cost aspects, and here is a full turnkey solution, we'll come and install everything for you and get it up and running, that's when we can make the maximum impact.
And what will be your added value? Your most added value?
The only turnkey solution provider. So from 2028 onwards, our business model pivots to being a turnkey solution provider. We will start with one machine, which is this first roll-to-roll via filling machine. We'll start to sell it to the industry, not just use internally, but also sell it to other manufacturers. So we'll sell it like the way ASML sells. We'll have service people, we'll have people who to train, and all the process and design rules are codified in software in the machine.
Yeah, you mentioned via filling.
Yeah, via filling.
That's the most important process.
It's a very first step to go towards multi-layered PCB, even for IoT devices.
And then you will build on, add new processors, next processors.
Yes, as we speak, we have a full roadmap of multiple machines. The first one is indeed a via filling machine, but then after creating the vias and the circuitry, you need to start assembling components. And how do you assemble components on a very thin plastic film like that? We are already doing that, but they are being done by using the current traditional assembly machines. There also we are going to create a paradigm-changing assembly machine that will also be an add-on to this via filling machine as a second offering. So we'll add more of these missing links as I call, and eventually by 2023, we'll start supplying full production lines. As they say, how do you eat an elephant piece by piece? That's exactly what it is about.
Building full production line.
Full production line.
Is a production line that can print whatever printed PCBs you'd like.
Indeed, within the subset, as I mentioned, the number of layers, maximum 6 layers, not high power electronics and so on, but by far up to 65% of PCBs can potentially be
65%?
In the global PCB market is now $80 billion or euros, is going towards doubling in the next few years. So you can imagine 65% of this is an enormous chunk. And if a lot of applications can be diverted from these edge technology to Tracxon's technology using our solutions, would be an awesome impact, also sustainability wise.
Do you also foresee printing active components on it?
Printing active components has been researched by many R&D institutes. The honest take on it is that it is possible to print, but does it make sense to print? So I mentioned the very first thing I mentioned about a customer is a MinkTech. MinkTech is not just a circuitry, it's a long sensor of 50 centimeters at least long, 500 millimeters. There is a circuitry, but there is also a printed strain sensor. So it's all printed. That can be printed. You can also print resistances. We can also print some kind of, let's say, temperature sensing materials. These can be printed in a good and efficient way. But printing of microcontrollers or, let's say, batteries and so on, yes, it's possible, but it's a lot more efficient to assemble them, because they are very well packaged and they are high performance and very cheap. That's why, I don't want to introduce too many jargons, but technically, I have to say this, by the way, printed electronics refers to printing of circuitry and sensors. When you add components and chips and batteries to it, it becomes hybrid printed electronics. And that's exactly what we are offering, combining everything to create fully functional PCB assemblies. Otherwise, it's just a base is there. Who's going to add all this? It will bring its own challenge.
We've had a printed electronics company, or Mutrax. Probably you know the origins. They originated from OC. Yes. Eventually, they went broke. They had a lot of troubles with material suppliers. They were not big enough to be supported. Do you have any technology originate from Mutrax, or is it just completely from the TNO origins?
Yeah, we know Mutrax very, very well. Unfortunately, indeed, they went bankrupt, and sometimes you can be too early in the industry, and the supply chain around you, or ecosystem around you is not robust enough. Things like this happen, unfortunately. And as Tracxon, we are almost solely based on TNO technology, whole center technology. But I must also highlight that in the last 3.5 years, we not only added on top of it, but for example, these via filling machines and the assembly concept, it's fully Tracxon in-house development. So with Mutrax, we have no connection, although we know them very well.
Any lessons learned from that case?
There are many actually similar to Mutrax, because I've been following this also. My colleagues have been following these companies for quite some time. It is, as you rightly said, it's a value chain play. If material suppliers are not able to deliver the quality and the cost and so on the way you want, and if they consider you as too small to engage with, then the game is over before you start, unless you have your own material. So this is where, I mentioned these 4 pillars, we can control the other pillars except the materials. That's where from day one, Tracxon has strategic partnerships with 3 different material suppliers. And they also like us because they say, these guys can be disruptive, so let's give them all the support possible so that we can all succeed together. So that is from day one the key priority. That's a lesson.
Do they supply the same material, or is it a mixture?
So they have these off-the-shelf materials, and when we plug them in and we say, but the properties have to be tuned, they're just a phone call away from giving us an improved lab formulation. That's a relationship. Right now, I can mention one example without telling the customer name. We are working for a customer to create a specific pressure sensor. The pressure sensor has to respond to a certain pressure range. And there are many material suppliers that we can just buy from and start to print. But the properties of the material has to be optimized based on the application. So we call this supplier, I would say collaborator, and say, hey, this is the current curve you see as a response. Can we have a curve that is 50% above in terms of the y-axis? They are working on it as we speak in a closed wallet manner. That is the collaboration we are talking about.
Why is the via filling process difficult? What is it about? What do you have to do to establish it?
If you showed this printed roll, in a real life scenario, when we are installing, let's go fast forward to 2033. Let's assume we are installing the full production line at Flextronics or Jabil or Molex, for example, independent of the location. The printing line has to run at least at 10 meters per minute. That's a very high speed. Now the via filling machine currently is seen as a standalone machine, because we are starting with that. And the first, when we sell it to the market, it will be a standalone standing in a corner. But the eventual goal is to have inline. Our machine should be able to take in a roll of plastic foil or paper, functional paper, an empty roll. When it comes out on the other side, it has multi-layered circuitry, both sides with vias in a single flow. That's when you achieve a true disruption.
Continuous process.
Exactly. So imagine now the via filling machine has to create vias at up to 10 meters per minute. We are talking about at least 1,000 vias per minute. And when in a moving roll, how do you use a laser, for example, to accurately drill down to plus or minus 10 microns in that speed, and also fill it without having add traps and this and that, and also be able to have the right electrical properties? Why are we best positioned to do that? Yes, it's the process is nailed already. We have already shown, if you look around here, you will see the most complex via filled printed device in the world. Process is mastered. And the individual building blocks are very well known to us, because we know exactly which machine, which module has to fit in the line. The last bit is the integration. And that's what we are solving as we speak, and that's the biggest challenge. Speed is a challenge. Accuracy combined with speed is the biggest challenge.
Can you give me some more details about what is the via filling? So what happens in one via? What kind of material is deposited into the via?
Then let's take this famous example. This is traditional PCB as we discussed already. Copper, and there's a plating inside, plating material. The alloy I'm not very sure of, but it's very close to the other materials in the same, yeah? Now consider printing, it's almost the same. If we print silver on side A and side B, the via filling material will also be the same. We are not going all over the place, we are choosing, and we are going to prescribe to the customer, hey, for this silver, you have to use this material, and that's the standard for this machine. If you use copper, this is the standard for the machine. Only two types. So there is a continuity in terms of material, but also electrical properties. And if you look at zoom in into a via, you see, of course, a hole, just like holes here. No secret, laser is the only way to drill. We can't use mechanical drilling. For that speed, it's impossible. So there is a laser that's drilling at very high speed with scanners and so on. And then we are using there, I cannot tell more, a special dual deposition process. There is one type of deposition followed by another type that work in conjunction that ensure along with the vacuum that the via is filled perfectly at those high speeds. And then the so-called foil roll called the web, it moves further to a heating zone. So now there is also one of the innovations here. The heater can either fully cure the material inside the via or only dry it temporarily so that you can use it immediately for printing. Then you also save the energy quite a lot. So this is, if I kind of zoom in, this is all I can say as of now. On the high lines, it's a full roll-to-roll process. I put a roll in, empty roll of foil. It comes out with filled vias in the design and locations you want in a digital manner. And also for the downstream process, the right markers, so you can take it and do the printing afterwards in a very accurate manner.
And you think that you will be able to deliver the equipment to the market in 2033?
It's good to be bold and ambitious. So what we are trying to do is to create the first prototype machine for internal validation by June 2026. So basically 8 months from now, a full roll-to-roll machine with reduced specifications will be ready for testing at Tracxon. Then we are already working with some key customers. We'll show them the proof points based on their designs. And we are starting to build a so-called alpha machine. Actually, that machine is ready already in mid-2027. And commercialization happens early 2028. So already by 2028, we start to sell these via filling machines to the market. And in fact, in 2027, for those early adopters, we'll also sell the alpha version with some bugs and so on, so they can work with us to improve that machine. So timelines are ambitious, but we are also executing in a proper way to get there.
Yeah, and in the meantime, you also make money helping current customers.
Absolutely, and this is why the machine building team, of course, they are going to interact with the production team closely. But the machine building team we are hiring right now, people are coming in. They'll solely focus on getting the via filling machine ready, full focus. The production team headed by our operations head Raghu, they are focusing on helping the current customers by doing the manufacturing services, because the more we manufacture, the more there is proof point for our technology and the more the learnings for the machine. This is different from a typical machine manufacturer, who can do a great job, but we are also optimizing the process one-to-one for that machine using these projects that we are doing for customers.
And products that were partly made through your machines are already on the market.
Absolutely.
And also medical devices that are FDA approved?
So FDA approval, because we are only now 3 years old, so the approvals can take a lot of time. This Mink Tech, I mentioned the customer, they supply for the wellness application. So basically they don't need this healthcare FDA approval or CE approval, but they have to go through certain processes indeed. I also mentioned about TouchWaves, a whole center TNO spin-off. They also have certain prototypes in the market. And I can't mention the name, but one Israeli company already has product in the market. And then we work with multiple IoT customers who have plugged in pilot batches in the market. So the CE FDA approval process, we have multiple customers working on that, but they have not yet passed that and implemented it for medical grade application. That takes a bit more time.
And how about financials? Will you be able to become cash flow positive in the coming years, or do you still need a lot of investment to get this rather big equipment to the market?
For sure, because let's assume a scenario where we say the via filling machine is ready and it's commercialized 2028. And we are also doing manufacturing to have more validation and application development.
And you need to scale up.
Yes, but if we stay with this recipe, purely based on the manufacturing scaling up, we already have customers going towards 100,000 to 500,000 pieces with us. So then if we focus on this mix, then we can reach a break even in, I would say, 3 years from now, including the machine building part. But we want to have this make a huge impact to create this giant of a machine with so many modules, with full validation and testing and so on. That needs a lot more investment, of course. If I go back, if we ask for a mission of Tracxon, just one statement. They say this in America, the BHAG, the big, hairy, audacious goal. Our BHAG is that our technology replaces 10% of these PCBs in 8 years from now, basically 8 to 9 years from now. So I started last year, so 10 years. Now it's 8 to 9 years from now. And that means a market size of 15 billion euros. Because at that time the market size is 150 billion in total.
Potential is 65%. Your BHAG is 10%.
Yeah, if you go to 10%, then you can imagine to be able to tap into the market that is that delivers 15 billion euros, you need at least a few hundred millions in investments to get to that ambitious scale.
Local present everywhere.
Absolutely.
Have services.
Absolutely. And this is the let's say the conundrum at Tracxon. Actually, if we say, okay, let's only focus on the manufacturing services and remain as a team of 20 people, we can potentially break even next year. But by doing that, we are confining this wonderful sustainable technology to a small niche group of customers. That's not the goal. Let's make an impact. I mean, again, maybe I'm being too, I wouldn't call it ethical, but too principled, I might say. People walking around here, we have this one message, right? And that is every year, if you look at 2033, this is the target, 2034, every year we'll be burning or burying e-waste from PCBs that are equivalent to 1 million African elephants. One African elephant is about, male elephant is about 6,000 kilos on average. Think about 1 million African elephants. That's the weight of the e-waste we are generating with these. For comparison, the Airbus A380 is less than 50 African elephants. And for us, yeah, if we try to focus on staying small and niche and breaking even quickly, then we won't be able to make an impact there. And thankfully, the investors also believe in that, and we are also in the right ecosystem to do that. That's indeed the full story of why we are doing all these things.
You, of course, are CEO. You're not daily involved in system engineering, but what do you see in Holland? What are our advantages, disadvantages in developing products like this? Like you combine materials, processes, equipment. What do you see? What are our strengths in system engineering and what are our hurdles?
Without trying to please anyone, this is also the fact. In terms of ecosystem where all the players in a full system, the value chain, they come together here, right here. Yeah, the Brabant, the Eindhoven region, and a bit broader as well. All kinds of machine building partners, all kinds of innovative mechanical, electrical, and designers and so on and so forth, but also hands-on engineers, they are here. But TNO, our parent company, is 3 kilometers away, so we collaborate with them for the process constantly. So from that perspective, this is possibly the strongest location one can hope for. But where we are lacking as an overall, if you look at the overall value chain, is indeed for material suppliers, we are typically dependent on Americans, some Germans, and so on and so forth. All the geopolitics is always a bit of a game. And it's also the same with respect to big customers. If, for example, Netherlands were like Germany in terms of size, in terms of industries, and so on and so forth, there they have these lot of automotive industries, for example. They work in the so-called BMBF programs with multiple universities and Fraunhofer's there. Here, it's quite a bit less in terms of these big customers. But purely focus on the machine building part, every single system of a complex machine can be done here better than any other region. That's how I see it.
Is it a disadvantage to have such a big oxygen-consuming company like ASML near? Is it you have to compete with talent, maybe resources, engineering bureaus?
I'll explain why it's a blessing in disguise. Because I mean, when I go outside of, let's say, this region, maybe to the US or to Asia, Eindhoven is not very well known as a city, even though we are super innovative here. And this is changing, by the way. But as soon as we say ASML, most people, their eyes light up. So that's our calling card. Hey, we are from the same region as ASML. I also mentioned Philips and NXP and so on. That is actually lending us credibility. Otherwise, you just mentioned how many people, you're a small company, right? Here I am as a CEO of a small company with this big vision and going out to Japan, for example, and talking about replacing 10% of the PCB market. Why would they take me seriously, right? The reason is the calling card is, hey, look, we are from this region where ASML is located, by the way, also the headquarters of Philips and so on and so forth, then people take notice. That is for sure a great thing. Second thing is, because of ASML, there are so many engineers that have come to this region like a magnet, but after a point, they are also looking for a challenge or a change. So we are able to, honestly, just give you an example. Just after the funding towards end of August, after summer break, I had advertised on LinkedIn for a vacancy for director of machine building. Few days, I spent only 70, 80 euros per LinkedIn just to publish. I got 70 applicants, 70. That helps because the talent is here, but the curse part is indeed the salaries have been quite pushed up, and if I have to hire people from outside of the EU or even outside of Netherlands, they have to come here and they see the rents and then say, oops, what is this? You have to pay 2,000 euros for a 2-bedroom apartment. That sets a barrier much higher. That's a curse.
Those 70 people, they were from around, or were they international?
So full mix of people. We had internationals all the way from Korea, India, Turkey, even US and so on. But there are enough local people. That's what I was mentioning. When we zoomed in on the top 3 candidates, they were already here. Not because we didn't choose them because they are local people, but they already fulfill all the criteria without us having to go through the drill of applying for a visa and waiting for a few months, finding a housing. That is kind of taken care of. And that's the advantage of being in this region.
There's, of course, a lot of attention. Energy is going to sustainability. Yes. Sustainability is getting rather important. Are companies serious enough? Do they take it serious enough? And is the legislation there to get this done? From your position, because you're what's one of your targets?
The answer is yes and no. The companies are serious, but not serious enough. This is very important because that's the focus also of our CTO, Corné Renthrop. He focuses on multiple European partnerships, mostly via grants, to make sure the ecosystem moves in that direction. It's all an ecosystem play, and thankfully legislations are kicking in. Now carbon penalties, and also automotive industry is now scrambling to use more eco-friendly and recyclable materials. All these are good, but it's not good enough yet. I don't want to pull names here. There are a few companies also in this region. They are super interested in Tracxon's technology. They could see the benefits clearly, but they say sustainability is super important if we could match the cost of Chinese suppliers. But we can't start with that because there the value chain is so established, lower cost in terms of workforce, but also machines are fully depreciated from the traditional PCB industry. So we can't start with the same comparison. We have to start with the total cost of ownership. What does it mean is that it's not just creating the product and transporting them, but also what happens to the product at the end of life. And that's where all the legislations are coming up, and they will really help us. I mentioned this 2033-34 target. We think in the next 5 to 7 years, this will become extremely serious and inescapable. And then the good intentions will translate into actual actions. And we are seeing some trend already in that direction.
What is your biggest concern?
The biggest concern for the business model is, end of the day, while there is a lot of traction for Tracxon, as I mentioned, the proof of burden is also on us. If we don't, let's assume that we stop all the manufacturing activity and say we are only building the machine. If we bring the machine to the market, unfortunately, the industry is not capable enough to be able to both print and assemble and so on. So we have to establish these proof points so that eventually the big giants of this world can see, Tracxon has shown 100,000 pieces of an IoT device, multi-layer with 20 components at 99.9% yield. I want that too. That proof of burden is the biggest challenge, both in terms of activity and also in explaining to people why we are doing these two things. Also, some investors are, why don't you just build a machine? Because that's the strength of the region. And my answer was, yes, we can build it, and then do what? Yeah. That is the problem. But if a giant or multiple giant companies adopt Tracxon's technology, that's the biggest success. If we can make a real impact in terms of sustainable manufacturing, we would have left our good footprint on the world, not carbon footprint. That's the biggest impact. And of course, we are a shareholder funded company. It has also deliver economical value. And that's exactly where the ambition is big, but the end goal is replace as many of these, avoid these being used for all the wearables and IoT and other kinds of PCBs that are possible, because they all end up as an e-waste. It doesn't make sense that we can't ignore electronics. We need the electronics, so find a way to solve this problem. That is the why we are doing this. Sleepless nights and so on and so forth. Yeah.
I wish you good luck with that, Ashok.
Appreciate it. Thanks a lot.
Thank you for having me.
My pleasure. It was a great interaction with you. Thank you so much.
This was René Rijmakers for Bits&Chips. Thanks for watching. And if you like this video, please give us a like. It really helps other people to find this content.